All right, lesson 2, product and quotient rules. So again, we are looking at derivatives. We talked about a few in lesson 1, and now we're just going to be compiling them together. So this is rule number 6. If both f and g are differentiable functions, then when we multiply them together, f times g, and take the derivative of the product of these two functions, we can write the derivative as the function f times the derivative of g plus the derivative of f times the function g. This is another way that we can write this in different notation. So the derivative of f of x times g of x is f of x times the derivative of g of x plus g of x times the derivative of f of x. Now, because we have a plus sign in the middle, it actually doesn't matter which one you do first and second. However, when we do the next rule, the order will matter. So for product rule, there's a plus sign in the middle. You take the derivative of one times the first, the derivative of the first times the second. That's essentially how we do this. So in example 1, we have the function x times e to the x. I'm going to split these into two functions, x times e to the x. So that means y, or you know what, instead of using y, I'm just going to use g and h. I think that'll be a little bit simpler. G is going to be x, so g prime is going to be 1. H equals e to the x, h prime equals e to the x from lesson 1. So that means f prime is gh prime plus g prime h. So putting this all together, g times h prime plus g prime, which is 1, times h prime. And if you're really clever, you could factor this. And that is my final answer. I don't like how close I drew that. Let's try that nice again. Sometimes I get a little bit picky about how I draw my boxes here, but essentially that is the rule. So anytime you have a product of things, you can always split them into two different functions, find their derivatives individually, and then put them into the product rule. Example 2, again, I have two functions that could be multiplied together. Let's call this g. Let's call this h. Within g and h, you'll notice that there's also a plus sign in here. This is going to be my power rule. This is going to be the constant rule. Power rule, power rule. So let's make a list. G is 2x cubed plus 5. G prime, using the product rule, 2 times 3 is 6x squared, and the 5 is a constant, so it goes away. Looking at my function h, 3x squared minus x, h prime is 3 times 2 is 6x minus 1 for that. So then finally f prime is gh prime plus g prime h. G 2x cubed plus 5, h prime 6x minus 1 plus g prime 6x squared times h, 3x squared minus x. And then the ugly bits happen where we have to FOIL this out. So this will be 12x to the 4 minus 2x3 plus 30x minus 5 plus 18x to the 4 minus 6x3. I think that's it. So combining like terms, I see 2 4s there. 12 and 18 make 30x to the 4. And then minus 2 minus 6 gives me minus 8x to the 3. I'm not seeing any x squared, so I move on to 30x minus 5, and this is f prime. All done. There we go. Not the cutest little thing, but very, very doable. In our next example, we have a square root. So here's one function, and here is the other. If g is square root x, this is the same thing as saying x to the 1/2. So g prime is going to be 1 over 2 root x. H is 2 minus 3x. H prime is going to be negative 3, right? Because I have a constant and then power rule. And if you don't remember how I went from here to here, please go back and look at lesson 1A. All right, so then my final derivative is going to be root x times, oops, negative 3. Uh-oh, my pen is freezing here. So root x times negative 3. Let's see if it'll let me now. There we go. Plus 1 over 2 root x times 2 minus 3x. And this is not really a good way to simplify this. I could put this over a common denominator. That would give me negative 6x plus 2 minus 3x all over 2 root x. Let's see, I can simplify this a little bit more. 2 minus 9x over 2 root x. That's a little bit cute. Certainly doable within a given amount of time frame. And that is our final derivative. All right, so if you have a function made up of a product of different things, just split them into pieces and follow the product rule. Okay, here's a bit of a word example, slightly more complex. Find the slope of the tangent to the graph. Slope of the tangent to the graph. This is a really fancy word for find f prime. At the point 1, 5. So we're looking for the derivative at a specific point, which means we are going to be inputting x equals 1 once we find f prime. So we are looking for specifically f prime of 1. Again, splitting the 2. Now this one looks very similar to the one that we just did. Is this the same function? 2x3? No, it isn't. Okay, let's do it separately then. So if g is 3x squared plus 2, then g prime is 6x. If h is 2x cubed minus 1, then h prime is 6x squared, which means f prime is 3x squared plus 2 times 6x squared plus 2x cubed minus 1 times 6x. Essentially, multiply these two and then add the product of those two. And let's see if we can make this a little bit prettier. 18x to the 4 plus 12x squared plus 12x cubed minus 6x. Ooh, this does not get any prettier. That's about as simplified as that gets. So then f prime of 1, I'm just putting 1 for all of this, 18 plus 12 plus 12 minus 6. So let's see, mental math. This is 30 plus 6. This is 36 is the slope of the graph at the point 1, 5. And I'm done. All right, let's see. Example 5, find if the function f is the square root of g, where g of 4 is 2, meaning the coordinate here of the original function g is 4, 2. And g prime of 4 is 3. Find f prime of 4. Ooh, interesting. How would we go about doing this question here? Now, we're supposed to use our product rules. What could we do here? This is the same as saying g to the power 1 over 2. This is a chain rule question, I believe. Let me just double check. I'm going to pause the video for a moment and double check that this example is in the correct spot.